If you install npm packages, you're a target. Maybe not today, maybe not this week, but it's definitely coming. We have had hundreds of packages compromised in the last few months alone, and it is not slowing down. So instead of worrying every time one of these has come up, I actually went and locked down my own setup across npm, pnpm, and bun, and it turns out most of the stuff that would have saved you takes about 30 seconds to set up. So in this video, I'll take you through the 7 changes that I made, from a single line of config change that kills the most common attack outright, to free tools that the attackers themselves admitted would catch them before the package even reached your machine. Let's get into it. The first and most simple one is just stop downloading new packages. Most of these supply chain attacks get caught within hours, so if you just don't install brand new versions the second they drop, you actually dodge most of these supply chain attacks entirely. All of the major Node.js package managers now offer some form of release age gating. For npm, you set this in the npm RC file, and it's set in days. For pnpm, you can set it globally in the pnpm config.yaml file, or you can set this on a per project basis by using the pnpm workspace file, and this value is actually set in minutes. And it's also worth noting that since pnpm 11, this actually has a default to 1 day, so even if you don't set it, you still have some protection. For bun, you set this in the bunfig.toml file, either globally or again per project, and this one is actually set in seconds. It really amazes me that across 3 package managers for the same setting, we have landed on 3 different values, and it kind of sums up this ecosystem quite well. Once you have this set, if you then install a package like tanstack's React Start one, you can see it doesn't install the latest version, it actually installs the most recent one, which fits my release age criteria, which for me was 1 week ago. Now, if you ever need to bypass this, perhaps there's been a security issue with the package that you're installing and you need to install the latest version, you can still do so from the command line, but do watch out for LLMs here as well, as I've actually seen cases where LLMs just use this to bypass and install the latest versions anyway. Another thing to keep in mind is that npx and bunx don't respect this setting. They actually still install the latest version, and there is an open PR in bun to fix this. Now, while we're in these settings, let's go ahead and turn off install scripts for npm as well. pnpm and bun actually have this behavior by default, so there's nothing to set for them. If you didn't know, when you install a package, that package is actually allowed to run its own code right after it's been installed, and this was done for legitimate use cases like compiling native code or downloading a binary, but the trouble is nearly every single supply chain attack has used this method to run malicious code on your machine right after install. If you do find a package that has a legitimate need for one of these scripts, you can still explicitly enable it. In pnpm, when you install a package that has post-install scripts, it will actually tell you, like ES-build here, and then you can run pnpm approved builds to choose which ones to allow, and this actually sets your pnpm workspace allow builds config, and you can also just use the allow build flag on the install command to do the same thing. For bun, as I said, it stops these install scripts by default as well, but it's worth knowing that it actually has a curated list of packages that are allowed to run these scripts, and that includes ones that I have installed like ES-build. You can opt out of this by adding trusted dependencies into your package.json. This way, only packages you explicitly allow will be able to run post-install scripts. It does also say that if you set the array to empty, that it should override that default list as well, but it doesn't appear to be working for me, and it seems to be a bug that I found on GitHub too. The workaround for this at the moment is just to put one value in that list, and then the default list is ignored. With bun, you can also run bun pm untrusted to see which packages want to run scripts but aren't trusted yet, and then you can run bun pm trust to allow one, or just add it to that trusted dependencies array. You can also entirely disable scripts in bun by saying install scripts to false in your global bunfig. For npm, this is a little more difficult. Honestly, just don't use npm, use pnpm, but if you really have to use npm for some reason, you can get a similar allow list behavior by using lavamote's allow scripts npm package. This way, it's just an allow list in your package.json as well. The third tip is to block Git-based dependencies. With npm, a dependency can actually be declared as a Git URL, which bypasses the registry, and can even ship its own npm RC that re-enables lifecycle scripts. This was actually one of the tricks used in the recent npm supply chain attack that hit Tanstack. You can stop this by setting allow git to none in your npm config, which blocks them entirely, and the other option is to set this to root, which does allow Git-based dependencies to be installed, but only if they're declared in your root package.json, so likely explicitly set by you. For pnpm, this option is block exotic sub-dependencies. When this is set to true, only direct dependencies, so those that you have listed in your root package.json, can use exotic sources such as Git repos or direct tarball URLs. This option doesn't exist in bun yet though, but there is a PR open to add this, so maybe we'll see it soon. As a bonus to end the tips that involve config changes, pnpm actually has a trust policy setting, which we can set to no downgrade, and this means that pnpm will fail if a package's trust level has decreased compared to its previous release. So if a package was previously published by a trusted publisher, but now it only has provenance or no trust evidence, installation will fail. This should help catch those attacks that find ways to bypass the usual publishing processes. Tip number 4 though is probably the most powerful one, which is using a tool that actually looks at the packages you're installing and can audit them before they ever touch your machine. For that, we have 2 powerful and completely free tools. The first one is MPQ. You can set this up by creating an alias for your normal npm, pnpm, or bun commands, so that every time you run an install, it actually checks a few things. It will scan for known vulnerabilities against Snyk's database and flag any package that's less than 22 days old. It will catch typo squatting, which is where someone's published a package like Express with 1s, hoping that you'll make a typo and install that one instead. It will verify the registry signature and build provenance. It will warn you when a package has pre- and post-install scripts, and on top of all of that, it checks for basic things like the download count, if there's a README, a license, a repo URL, and what the maintainer's email is, and if that domain is even still registered. It does all this and then gives you an interactive report on your packages where you can still decide whether you want to install it. The second one is Socket Firewall. This is actually the one that I use, and again, you alias this for all of your usual package managers, and this one actually supports ones outside of JavaScript too, like Python and Rust. Similar to MPQ, when you run an install with this, it will check Socket and block any human-confirmed malicious packages, and it will also warn you on any AI-detected threats, which are ones that haven't been human-reviewed yet. To be honest, I mainly chose Socket Firewall as it was the one that I heard of first, but I also trust Socket as they've caught a lot of the recent malicious packages, and the attackers even did an interview where they said that Socket will detect the malware before the package even reaches your machine, which is a pretty good advert for them, and I also like that it supports more than just JavaScript with UV, pip, and cargo. If you do install either of these, you'll want to make sure that you clear your package manager's cache, just to make sure that every installed package is checked by the firewall. Tip 5 is about your log files. Your log files are where the actual download URL for every package lives, and the problem is pretty much nobody reviews their log files in a PR. So if someone opens a PR against your repo, they can quietly edit a resolved URL to point to a package that they control, and also set the matching integrity hash so that nothing looks off. Now, the next time you run an install, you're pulling the code from the attacker's server. Good news is though, if you're using pnpm, you're not vulnerable to this one. It doesn't keep those tarball sources that can be swapped out, and it also won't install anything that's in the log file but not actually declared in your package.json. I couldn't find any concrete information on bun though, so that may still be vulnerable to this. The fix if you're not using pnpm is to use a tool called lockfile-lint. You install this as a dev dependency, and it validates your log file, checking every package resolves from a trusted host, like the npm registry. It checks that resolved URLs actually match the package's name, and it also checks the integrity hashes are real as well. If it suspects something has been tampered with, it will fail the install. Tip 6 is to stop using npm install in CI and production, and instead use clean install. The command for this in npm is just npm CI, and for bun and pnpm, you actually add the frozen log file flag, but they also have CI commands as an alias that do the same thing. pnpm actually uses this by default if it detects it's running in a CI environment. The clean install command installs exactly what's in the log file, nothing else, and if the log file and package.json don't agree, it just stops and throws an error instead of guessing and installing anyways. So this should prevent an attacker from sneaking a swapped version in. None of this works though if you're not committing your log file in the first place, so do make sure that's in version control and not in your git ignore. And I'll admit, when I first started learning to code as a kid, I actually thought you were meant to ignore these, so I'm glad I learned to commit them. So those 6 tips were mostly config and tooling, but there's also some habits that you can adopt to help you avoid attacks. The first one is to stop blindly updating everything. You may have run npm update or the other versions of this command before and just updated every dependency to its latest version in one go, but that's the kind of exact behavior these attackers are hoping for, so actually go through these upgrades and ask yourself why you need to upgrade it. The second habit is becoming more and more relevant. Just use fewer packages. Every dependency you add is another attack surface, and most of these attacks spread through dependencies of a dependency, so it's genuinely worth asking why you need that library. Some common examples I see of this are things like Lodash for functions that can be done with a small snippet of code, or Axios when fetch can do the same thing. The reason I say this is becoming more relevant is in the age of agentic coding, it's pretty easy to get AI to write a few functions for you instead of using a dependency. The third habit is pinning dependencies to an exact version, so an upgrade is always a deliberate choice, but just know this actually only locks down the packages that you choose in your package.json, and your dependencies can still use their own ranges, which is exactly why that cooldown from tip 1 matters. All of these combined should give you some peace of mind that you won't accidentally install a compromised package. They're not invincible, but they're a lot better than nothing. The ultimate tip is just to run everything in a hardened dev container, but I've always found that to be a bit of a hassle, so I end up falling back to local development. If you know any other way to protect yourself from this kind of attack, let me know in the comments down below. While you're there, subscribe, and as always, see you in the next one.